Here I am going to talk about short range technologies. What I am not covering are the barcode reader and QR code. Maybe I will briefly touch upon that before we go into these technologies, because this is also kind of communicating information in a near range region. So you might have seen in many shops about the barcode, which is nothing but a black and white lines, which is encoding some bit pattern here. So what is done is a red light is flashed on it, which reflects the signal back to the reader. Okay, the barcode reader will also be reading back what is getting reflected. Based on the black strip or white strip, you know that black color always absorbs the light, whereas white reflects it. So based on the reflected light, the decoder on the barcode reader will be able to find out what is the bit sequence which is stored here in the barcode, and based on that that information will be passed on to the system at the back end, and there will be a database which will match with the number what is being read, and then the item and the cost of that, which is getting printed on the thing what you see. So this is how barcode works. And then QR code is a 2D barcode, okay, because this is supposed to be considered to be a one single dimension barcode. Though it is drawn as a 2D plane, the information is stored on the single direction. Whereas in QR code, the information is stored on a 2D, really in 2D. You might see that there is a square like this on any three corners of the QR code, which is to identify that this is what it is being scanned. What is being scanned is a QR code or not. Okay, that is the information which is stored there. And then there is a white strip around the edges. There will be a thin white strip to mark the end of this barcode QR code area. Okay, that gives you the border of the QR code. And then there are some lines which are meant for synchronization, because when it is reading, we need to have information about the horizontal and vertical direction, because the surface on which this QR code is pasted on may be a curved surface, then, or it may be not in the single proper direction, from the reader, QR code reader, a phone or whatever camera is facing it. They may not be in the exact angle, so there may be some deviation. So to compensate for that, there are some, you can see some dots are there which are meant for giving the distance between the pattern so that it can read it properly. And then there is a hidden information here which is read and then passed on to the system to find out what exactly is the QR code is. So this is the method of communicating back to the device without really having a physical contact with the system. Now what we are going to see today is about different technologies which also help us in getting some information back from the system or communicating to the receiver. And here also we are using here whatever barcode is a not touched, right? The thing is not being read with this, which is read by sensing it. So similarly, these technologies help us in doing some other information to gather. Now let us go one by one. What is each of them mean? And I try to give you only an overview, not exactly telling about the technology behind, but I will give you some flavor so that you understand a little bit, which is enough for you to design systems using these technologies. Now, what is UWB? It's a ultra wideband. It's called ultra wideband. As the name indicates, it's a wide band of frequencies, which is nothing but the bandwidth. Okay, what I call it as a bandwidth. Now, this is all in gigahertz. This comma is given as dot because the American style is some places where they don't use dot, they use comma for it. This is 1.6 and 1.9 gigahertz, 2.4. We saw Wi-Fi is in this ISM band, industrial, scientific, and medical band, which is an unlicensed band, freely usable by any systems in the industry or scientific community or in the medical community. GPS is here, PCS is here. They are not unlicensed, they are licensed frequencies. Whereas I am talking about only these frequencies which is in ISM band. And USB is also, UWB is also ISM band. Okay, that it can be freely, the spectrum is also free. I'm sure. Okay. Now let me talk about how does it work. One important thing about this spectral density, this is a power. Okay, how much power is being radiated by the transmitter for the receiver to receive them. These are all which will high power communication. That's why the range is also more for this communication. Like Wi-Fi is little much more than Bluetooth, but the signal strength needs to be higher, but the bandwidth is small. Okay, they are supposed to be radiating only in some small frequency range, whereas UWB is wider. That means you can transmit in a wider frequency, but the power that you can transmit using this UWB is small. It is dBm. dB you might have heard for decibels, which is meant for even audio or signal strength. We use decibel. dB. I think you might have heard about these things. It's a ratio of powers, power output by input. How many dBs of power attenuation is done, or radiated power is measured in dBs. dBm is okay. dB is a comparison of watts. Okay, suppose watt 1 and watt 2. Some power 20 watts divided by 10 watts. Logarithm of that is dB. Okay, logarithm of that ratio. If the measured values are in watts, it is called dB. If it is dBm, the ratio of logarithmic ratio of power, whatever we are talking about, they are in milliwatts. Okay, that means it's a smaller power. That means you can understand that if you are radiating only milliwatts of power, it cannot go beyond some few meters. So UWB is low power communication. That's why it is meant for short range communication. It is not, what we are talking about here is not for the long range communication. Higher frequency, of course, and a wider bandwidth and larger bandwidth we are using, but we are transmitting in terms of milliwatts, so that it is only can be sensed within few meters, not more than 3, 4, 5 meters of range. So dBm means that. Okay, so that is the limit. FCC is the Federal Communication Committee, which has some limits on what you can transmit and which frequency, and what power you can transmit is also limited. You cannot just have a transmitter in your home and then start transmitting very high power output, because it is going to disturb the nearby circuits and home. So they don't allow you to do that. So there is even frequency usage as well as the power that you can use are also limited. Even our Wi-Fi, we cannot transmit very high power in that frequencies. We are expected to be within the limits that is defined by the world standards. Okay, now UWB is nothing but a wider frequency is used. There short pulses are sent. Okay, what is happening is short pulses are sent, and then a transmitter is there. It is sending a short pulse. Okay, and then it will, whatever happens is on the receiving end is it measures how much time the pulse is taking for it to reach. Okay, so let me explain a little bit more once I give you more information. It is a short pulses which are predefined time slot that's sent, okay, by the transmitter. Now I will tell you where it is used and how it is used. Okay, as I mentioned, it's license free. This spectrum is license free. That's why they have limited the power that you can transmit, so that because you are using wider frequency range, they don't want it to disturb anything. So that's why it is low power and meant for only short ranges. Because you are transmitting very low power, it consumes low power. The transmitter also consumes low power. So we can use it in our IoT, and it is power efficient because we are sending only short pulses, not continuously transmitting. We are only sending small pulses over the time, okay, given time. So it is power efficient. The transmitter will not spend too much of power to send it. Because the bandwidth is high, as I mentioned, the frequency is more, you can communicate more information. We can actually reach up to this much of data rates. But in our IoT case, we don't want to use it for this kind of purposes. But what I'm saying is a higher bandwidth will always give you a higher data rate. But here it has to be more than 500 megahertz. That's why we call that ultra wideband. If the bandwidth is more than 500 megahertz, it's called ultra wideband. It is immune to multipath. Okay, what I mean by multipath is when you have transmitting this kind of power in a 3D location, because it is meant for indoor, so you will be doing it inside the car or inside a parking lot or maybe inside a house. When it is transmitting, maybe some receiver is there, transmitter is there, it will be receiving the same signal through multiple paths because it will be reflected from different direction and it will be receiving multiple paths. So same signal will be received with some delay by the receiver. But it has some immunity built in so that even if there is a multiple path, it will not be a problem for UWB communication. Now, I mentioned that it uses the time of flight. How much time does the pulse takes for it to come from transmitter to some receiver? Okay. You know that all this radio frequency, they all is like a light. So the speed of light is what is the time taken, and the speed of communication 10 power 8 3 into 10 power 8 meters per second. So based on this speed, you know the frequency, and then if you know the time, how much time it takes for the pulse to reach, we can compute the distance. Okay, if you know the transmission rate, okay, meters per second, and then suppose if you know at the receiver, transmitter is expected to send a pulse at this time, then receiver is receiving it at T2. Suppose the receiver is aware of that information, then it will know that based on the time delay in receiving the pulse, it will be able to guess how far it is from the transmitter and receiver. So it is able to find out the distance between the transmitter and receiver because it knows at which time a particular pulse meant for the particular receiver is sent by the transmitter, so that it will sense the time at which it is being received, and it will reduce the distance traveled by the pulse because it knows the signals take 3 into 10 power 8 meter per second as the speed of transmission. Now, the fact that a transmitter and the receiver should be knowing the time, because they should be synchronized in terms of time. They should be synchronized in the sense the clock running here and the clock running in the receiver, they should be synchronized. That means there should be some protocol running to make sure that there is no drift between the clock and they are in sync, so that they know what time the transmitter is supposed to transmit, and the receiver will be able to guess what is that distance. Okay, so this is how a transmitter and receiver is sensing the distance between two objects. Superior resolution in radar ranging, because its behavior is similar to radar, though it is not reflected energy. In radar, what you see is a transmitter is sending some signal and then reflecting. The flight is not drawn properly. Let me draw a little bit like a flight. So when the flight is reflecting back, a radar sitting here will be able to guess the time taken by the signal. It has to comprehend for 2D, distance of 2D, and then it knows the C, that is 3 into 10 power 8, and then it knows the frequency, and then it will be able to find out what is the distance of the flight from the radar. In radar, it is the reflected energy which is being used, whereas in this case, don't think that it is reflecting. The transmitted energy itself is used. On receiving, it is not reflecting back anything, but it uses the distance traveled, because it knows what time the transmitter is sending and what time it is receiving, because it is time synchronized, so that it can find out. Whereas in radar, you cannot expect that kind of a synchronization, and flight is, it could be enemy flight or enemy aircraft, so you don't expect some synchronization to happen between the radar and the flights. So that is a reflected energy. Okay, don't confuse it with the radar being there. It is also like a radar. It behaves similar to it, but the main purpose of UWB in our use in IoT is ranging, to find out the distance between 2 points. Okay, I hope this is clear. Now, what are the disadvantages of this system, this technology? The range is only this much, 100 meters, not more than that, because power is limited, and the frequency also such that it will be absorbed. Okay, if you remember, even 5G, I mentioned that they operate in this frequency. Even Wi-Fi 6 operates in this frequency. Dual band, 6 gigahertz is also there. Okay, 6 gigahertz also, I mentioned that they work on Wi-Fi. So all these are all, range is limited because of the absorption of this signal by the atmosphere, or by the building, or by the material, or human being, whatever. So they cannot get transmitted fast. That's why 5G uses smaller range, small cells, picocells, or femtocells I mentioned. They use smaller range but high data rate. The range is limited, but data rate is more because bandwidth is more. We are using a higher frequency. I am teaching a little bit of electronics to you, because IoT is closely tied to electronics. So little bit, if you are aware, it will be good for you. So one more problem with the ultra wideband is antenna design. What you design, how to make it radiate to a particular way. Okay, it's a little complex. That's why compared to Bluetooth low energy, UWB is a little expensive. Okay. Okay, now let me tell you where exactly it is used. Manish has mentioned this. I thought I will show you this. If you have not seen the videos, I expected that you should have seen this by now. Smart tags. And NXP is another semiconductor company which is very, very active in this IoT area. It is earlier Philips, and the semiconductor part of the Philips got into NXP, and they are into IoT and even 5G also. UWB transmitters. Okay, now let me explain where exactly it is used. Suppose the typical example that we saw here, we are having a mobile, okay, mobile, I am showing it like this, and then a key is there, okay, is tied with this tag. Now, what happens is, this is a transmitter. This is also an app. Now, apart from this, there are already some transmitters which are fixed in the location. Okay, they are also transmitting it to this, and then sensing the direction. Okay, so this app is somehow connected to them, so that they know how exactly, where exactly the tag is, based on triangulation. I said that triangulation is the technique used for locating a particular piece in a given in an area. So we should know the position of these other sensors, position P1, P2, P3, or whatever, and then maybe we are also having a UWB transmission. Then we will also know where exactly this mobile is. Okay. Now, based on the distance measured by these devices, okay, where this particular, now you may wonder who is the transmitter and who is the receiver. Very important point. This is the transmitter, and these guys are the receivers. Okay, these are all the receivers. Now this is very important to remember. Okay, so the tag which is tied to the key is keep on transmitting some information which is received by multiple devices which are positioned in different places, and we know those positions, and there is some someone is working on to find out based on these positions, we will be able to guess what is the place, the exact point in which in this key is there in the room. Okay, locating that key in a three-dimensional area. It doesn't matter whether it is on top of the sofa or below the sofa, because we are keeping the sensors. If you are having 4 sensors, 4 receivers, then we will be able to find out the 3D location. Okay, XYZ we can find out. If you have 3 receivers, then you can find out 2D location, only X and Y. So what happens is we are trying to find out the distance of this particular object from different points which are known. The positions of those points are known. So from this you will be able to find out where exactly the unknown tag is. Then that information is passed on to the mobile app, and it will guide you to this particular place, because mobile also has a UWB receiver, and you will be able to find out what is the position of this guy. Because of that, we will be able to guide the person towards the key. Okay, that's how it works. I hope this is clear. So it's a multiple receivers are positioned in different places, and we know the position of them, those receivers, and the unknown is only the transmitter. So transmitter keeps sending the information, and the receivers are deducing the distance between their unknown tag and the known receivers, and it finds out the position in the particular three-dimensional area. Okay, so it's a time difference of arrival as well as angle of arrival. Okay, it also deduces, even Bluetooth uses the angle of arrival, as I mentioned. This uses a time difference of arrival. It doesn't use the angle information, because it's a omnidirectional transmitter. Okay, so the 3 receivers for 2D location, 4 receivers for 3D locations are required to find out the exact location of an object in a few inches of resolution. Okay, so use cases. One of the use cases is a key, digital key Samsung uses for the cars. So these receivers are there in known places with respect to that car, and this guy is in an unknown place. So he is carrying a mobile. He sends the information to these receivers, and it also deduces that it's a proper, it's a proper key is used based on the information which is being sent, and then it will find out the distance between that person and the car, and as the person comes near, it will open the door of the car. Okay, this is how it works. And you don't need to be in a line of sight. Okay, because it is an omnidirectional antenna. It's not like an infrared. Okay, if you remember, we used to have a remote control which is having a IR, infrared radiation, where line of sight is important. Line of sight, so that you have to face it towards the TV, but that restriction is not there in UWB, because it has a multipath cancellation capability, as well as it's an omnidirectional antenna, so it can receive from any direction. So localization algorithms are to estimate the internode distance. Okay, you can even find the distance between the nodes also. And some indoor location based services are navigation aid within shopping mall. Okay, you can, if you are having an app on your thing, if you are interested in buying some particular item, then it will direct you to the shop which is having that item. So, and then airport, based on the gate you want to go, it can guide you, because throughout the airport they have put a UWB receivers, and they know your position, and it knows the target position where you are supposed to go, so it can guide you through the airport to proper place. So navigation is possible, either human being, or it could be a robot, or any other thing which can be, you can use this UWB technology to navigate in an unknown region. Tracking people and objects inside a building, we can do, like a key, we can track it. Locating goods stored inside a warehouse, Amazon may be using this. And tracking animals and pets, you can do. Okay, this, because this is a low power device and it's not very expensive. Okay, if you can afford UWB transmitters, which are very small system with a battery in it, so we will be able to use it for different purposes. Okay, I hope this is clear to you. UWB is a replacement for GPS. GPS for outdoor, UWB for indoor. Okay, it's similar functionality. Okay, so it ends UWB. Let me see, I have taken more time, so other things I can finish it fast. Okay, no questions. Fine. Now Zigbee. Okay, another short range technology. This is the IEEE number 15.4. It's a wireless technology, of course, developed as an open global standard, low cost, low power wireless IoT networks. Remember one thing, UWB is used for localization or finding the position or ranging operation. Zigbee is for IoT network. So different IoT devices, if you want to network them and then communicate information into between them, then Zigbee is used. Okay, so at least have an idea of where all it is used and what is the purpose of this different technologies. It is also operating in the same ISM band, unlicensed. Also, other bands are there. As I mentioned, ISM band is not only 2.4 or 5. Other frequencies are also identified for ISM band, 800 megahertz, 868, 900. They are all ISM band. Zigbee 3 is designed for noisy industrial environment. So it's basically used in industrial environment where lots of engines, machines are running and lots of noise are there. Radio frequency range noise is there. So this should be noise resistant. Okay. Whereas UWB is operating in a very home environment, which is very noise free. Okay, it's not that much noisy like in industrial environment. So Zigbee is meant for industrial environment. It has multiple topologies that networking you might have studied: point to multi-point, and mesh networks. So whereas UWB is only point to point, okay, and that also simplex. Only in one direction the information flows, not even two direction. And it has got a long battery life, low power, low latency, okay, relatively suited for IoT. More number of nodes can be there in a network of Zigbee, and it is encrypted, advanced encryption algorithm, which is 128-bit code, so that it will be difficult to anybody to decode and find out what is the value. So compression or the encryption is done using 128-bit AES algorithm, and we can have even 250 nodes in a mesh network. So it is meant for IoT networks. So we can have IoT devices with a Zigbee capability can be connected in a mesh network. Okay, I will talk about mesh network, what exactly it is shortly. Self-healing nature of Zigbee mesh network. Self-healing means I will even if there is a internal routing disturbances, suppose you have so many devices, suppose one device goes out of range or it fails, it doesn't boot up, then what happens is it can heal. Self-healing means it can recover from one or two nodes which are there in the network going out of the network or suddenly powering off or misbehaving. You can still recover from it. Okay, and some of the cases the IoT devices themselves will be moving. Okay, they will be in a different area. So the network which is formed is dynamic in nature, and it can recover from any changes happening to the nodes inside the mesh network based on Zigbee. It is the supports over the air upgrade. So someone asked me about how do you upgrade the software on the IoT devices. So this Zigbee network itself, you can move from 3.0 to maybe later on 3.5 or whatever. We can advance, go to the higher latest network protocol versions by over the air upgrade also. Okay, provided there is no changes to the hardware required for changing over to newer versions. So what are mesh networks? They are interconnected with other nodes so that multiple pathways of each connecting. So there is, if you see that in a routing, normal network routing, we have a fixed, normally, okay, if it is a connection oriented network and we have a fixed path, then connectionless and connection oriented we know. So it will follow a fixed path in the network. Whereas in the mesh networking, we don't have a fixed path of routing. even if one node goes, it will still try to connect with other node. Anybody can communicate with anyone. Peer-to-peer communication is there. So they will adjust to the changes happening to the mesh network. It is dynamically updated, optimized through sophisticated built-in mesh routing table. It maintains some routing table. So it is little bit power consuming because it has to run a routing algorithm, routing protocol, so that it can adapt to the changes happening to the mesh network. They are decentralized. Okay, there is nothing called one network is controlling the whole thing. Okay, there is a decentralized. That means even if any node goes, it can still survive. Okay, that's why it is meant for harsh industrial environment where devices can go out of reach. So you should be able to survive there. Anything can leave the network, it can still communicate. It is ad hoc routing provided. They provide a greater stability. Okay, ad hoc routing. That means even if one node goes off the mesh, it will still be communicating. So what are the applications? Smart energy, smart grid. So if you want to have like a smart city or industrial environment where you want to measure different sensors, voltages or pressure, or even smart gauges for power reading from different nodes. All this we can use it even for this HVAC, heating, ventilation, and air conditioning, and even controlling different medical devices or house automation, building automation. If suppose if you want to control the lighting for an entire building with one switch, this can be used because one communication to a particular node saying that I want to switch on all the lights. Suppose these are all lights which are having Zigbee communication. I can say that the whole auditorium needs to be light up when the movie ends. We can just communicate with one information, one command. It will all send to everything and all of them will light up. So this kind of control is possible in this mesh network. Okay. I hope this is clear. Hopefully, let me see whether any questions. No questions. I don't know. You guys are there now. Okay, no problem. Okay, NFC near field communication. This is how it is built. We have a this actually you might have seen this also when you are reading or transacting PayPal or some other unit. You use the NFC communication in your mobile. So what happens here is there is a antenna which is like a wound coil, and then it is packed inside a strip. Okay, NFC. There may be a barcode also on top of it, like a backup. If NFC is not there, barcode may be used. Okay, so NFC is nothing but communicating between a reader and a tag. A tag is having a small antenna, and then the reader is having a transmitter. Okay, so what happens here? NFC is it allows user to make secure transaction because you want to without touch. Okay, it is for communicating between a distance of 4 centimeters. Is for identity. You can what happens is this NFC tag informs back whatever information stored here. Okay, I will talk about RFID to explain how the information is transmitted. The reader actually sends some RF signal, radio frequency signal, which is picked up by the antenna here, and then it knows that it is supposed to send back some information. So there is a microcontroller also there, which is energized by the transmitted energy. When the RF energy is going, it induces some current here and then it powers this also because you don't need a battery also here. It can be a passive device, and then it sends back some known information which is stored here in an SRAM or a EEPROM. That information is read by the reader. Okay, so you will know that what is the information which is stored in the NFC tag without having any wire or any battery. It is a contactless payment. We will be using it, and the frequency is 13.5 megahertz ISM band. Again, it's for peer-to-peer communication, informing small amount of information to be communicated wirelessly. They store passive data. Tags are passive and they get energized by the energy coming from here. Okay, the reader sends a radio frequency signal which is powering this, and then it helps in sending back the information. So it uses RFID technology, which I am going to explain next, so that you understand what I am talking about here. Okay, NFC uses RFID to perform this job. Okay, now what is RFID? RFID is a radio frequency identifier. In Bangalore, they have started already. On toll, we have to fit a fast tag on our car, and when you are passing by, it actually receives the signal from the toll gate. Okay, toll gate, cars are having this fast tag, and then toll gate is transmitting some information, radio frequency, and this fast tag sends back the information based on the energy it receives, and it also sends the information about the car, who is the registered user of this car, and then the backend uses the bank, okay, to get the money deducted from the bank, and then it allows you to pass the toll gate without you stopping the vehicle. So FASTag is a technology which is using the RFID to communicate back some information to the toll gate using the RFID technology. So you get the identity of the car, and then the backend uses that information to access your bank account, which is already linked, so that you can deduct the money from there, and then it allows you to pass through the toll gate without you stopping. So for RFID is nothing but a tag uses an antenna to pick up the signal which is coming from the reader, and then it uses that information to activate the chip and read the information stored there and send back the information back to the reader. Okay, so this all happens in the millisecond range. So antenna is there. This is a tag which also has an antenna. The reader sends a RF signal, and then it sends back the response with the information. So it's an identity tag. So I hope this is clear. It's called transponder, which is communicating transmitter and receiver. There are active and passive RFID tags. What is used in the cars are passive tags, which uses the power coming from the radio frequency, whereas active tags are powered. Okay, nothing but they also have a power and they are transmitting back. And it is a line of sight within the reader, does not need a line of sight, so you can be within the range so that it can be tracked. So car need not have to be in front of the reader. Okay, so simple. I am not going to details of this. There are two things in RFID: near field and far field. Within 1 meter distance, it can be read in near field, and the lower frequencies are used for near field. And the reader transmits some information, RF signal, either one of these frequencies, and the tag sends back the information in terms of RF only, signal only, but it reads from the memory which is stored inside. Okay, it's called load modulation. Don't worry about this. Bit pattern is sent by switching on and off something inside it. Okay, that is called near field. Far field is a distance between the reader and the tag is more, 3.5 meter or more. Here, these devices may have passive or active tags. The difference between the near field and far field is this uses the radar technology. Okay, whatever is the signal which is sent is reflected back here, whereas here it is induced and then it sends back changes to the signal. Okay, whereas here it receives some signal and then it transmits back some signal. It's similar to radar, what is happening from the aircraft. So it uses a little higher frequencies for far field. Backscatter, because reflection is a backscatter, modulation is used for this purpose. So just have an idea that near field is just inducing some current, and then it's for passive tag. Information is passed back using the inductive current in the coil. Here it is a signal is coming here and reflected back here. Okay, and it is meant for a longer distance. That's all. And information stored here is sent back to the reader. That's all. You can read some of the links which I have given will be useful for you to understand more about this. Okay.